All right, let's be real. If you've ever written any Python, you know the feeling. You've got what should be a simple 20-minute task that suddenly blows up into hours of pure frustration. And it's all because of one thing: dependencies. It's like a rite of passage for Python developers, but does it really have to be this way? Today, we are diving deep into Python's infamous dependency hell and taking a look at a revolutionary tool that might just be the escape route we've all been looking for.
I mean, this quote from a developer on Reddit just hits the nail on the head, doesn't it? It perfectly captures that sinking feeling when you run pip install and your terminal just explodes with red error messages. And I want to be super clear here. It is not just you. This is a genuine, widespread pain point that's felt by pretty much everyone in the Python community. And that whole experience, well, it always leads to this exact question. It is so easy to start thinking, am I the one doing something wrong? Did I miss some secret, crucial setup step? But the truth is, you're not missing anything. The problem isn't you. It's actually rooted deep in the very architecture of Python's packaging ecosystem, and we're about to unpack exactly why that is.
Okay, so to really answer that question, we've got to look under the hood. This isn't just about a single tool being a bit slow or clunky. No, the complexity comes from some really fundamental design decisions that were made years and years ago, and they're still affecting us every single day. Let's break down what's really going on.
This table right here contrasts the two core philosophies perfectly. See, in an ecosystem like .NET's, things are declarative. All the information about dependencies is just right there, stated upfront in a file. But Python? Well, Python is procedural. To find out what a package actually needs, pip often has to download it and literally run code from a setup.py file just to get the list. This forces it into this slow, iterative guessing game where it has to download packages one by one instead of just building a full plan from the start. This single difference is the source of so much of our pain.
And that brings us to the dreaded SDIST, or source distribution. This is ground zero for the infamous, well, it works on my machine problem. See, when there's no precompiled version for your system, pip just downloads the raw source code and tries to build it right there on your computer. If you're missing a C++ compiler or some specific system library, bam! The installation just fails spectacularly. The entire burden of compiling the code gets shifted from the person who made the package to you.
Now, this is a really crucial point. Pip's notorious slowness is actually a feature, not a bug. It's true. Before 2020, pip was way faster, but it would often leave you with a completely broken environment. The community, rightly, demanded a fix, and the result was this correct resolver that uses backtracking. When it hits a version conflict, it has to go all the way back, download a different version, check its dependencies, and then repeat that cycle over and over again. It's slow because it's being forced to do the right thing in a system that only lets it see one tiny piece of the puzzle at a time.
So, all of this architectural weirdness has led to what I like to call a fragmented universe of tools, right? You don't just use pip. You need venv for isolation, then maybe pip tools to create reproducible builds, and probably pyenv to manage different Python versions. Each tool is like a patch for a specific hole, but it forces you, the developer, to learn and juggle this entire complex toolchain just to get what's considered standard in other languages. The amount of stuff you have to keep in your head is just immense.
But what if we could just wipe the slate clean? A new player has entered the game, and they're not here to add another tool to that messy pile. They're here to replace the entire pile itself. Meet UV, a revolutionary new tool from a company called Astral. Now, if that name Astral sounds familiar, it should. They're the geniuses who created Ruff, the unbelievably fast Python linter that basically took the whole community by storm. And they're applying the exact same philosophy here, rewriting critical Python tools in Rust. And this isn't some gimmick. Rust's performance and its ability to handle many tasks at once are the secret keys that unlock the incredible speed and power of UV.
And this right here, this just brilliantly illustrates UV's core promise. Remember that fragmented universe of tools we just talked about? Well, UV's goal is to replace all of them with a single lightning-fast program. This isn't just an improvement, you guys. It's a radical simplification of the entire Python developer experience.
So how in the world does it get this fast? Well, first, being written in Rust gives it raw native performance. Second, and this is the real game changer, is its intelligent global cache. UV will build a package once, just once. Then, for every other project on your machine that needs that same package, it creates an instant hard link. Think of it like a desktop shortcut that points directly to the original file. It uses zero extra space and takes zero time. And finally, it does everything at once. It parallelizes everything, downloading and installing packages concurrently to totally max out your machine's capabilities.
Okay, that all sounds great in theory, but what about the real world? Does it actually deliver? Let's look at the proof. Because the numbers and the names of the projects that are already switching over are frankly staggering.
This is the number you need to remember. UV isn't just a little bit faster. It is 10 to 100 times faster than PIP and other tools. This is not some small incremental improvement. This is a complete transformation of your workflow. What used to be your coffee break is now over before you can even get out of your chair.
I mean, this chart just says it all. For a fresh install of a pretty complex project, PIP takes 12 seconds. Poetry takes about 8.5. UV does the exact same job in just over 0.2 of a second. It's not just faster, it's in a completely different league of performance. It's not even a fair fight.
And this right here is where that insane speed translates directly into saving money. In professional settings, CI/CD pipelines are running constantly, shaving minutes off of every single build, every single test run. That adds up to massive savings in server costs and, maybe more importantly, developer time. It unblocks entire teams and accelerates the whole development cycle.
But hey, don't just take my word for it. This quote is from the official documentation of FastAPI, which is one of the most popular and cutting-edge web frameworks in the Python world. When a project of that size and influence gives such a strong, explicit recommendation, you know a major shift is happening.
And it's not just FastAPI. We're talking about key players in the data science and web worlds like Streamlit and Plotly. These are projects that live and die by managing incredibly complex dependencies, and their adoption is a huge vote of confidence. This isn't some niche little tool anymore. It's quickly becoming the new gold standard.
So, what does this all mean for the future of Python development? The crazy fast rise of UV isn't just about getting a faster tool. It represents a fundamental change in what we, as developers, expect from our tools. So let's wrap this up with the big picture.
Okay, it's really crucial to understand this distinction. UV is a brilliant, powerful client that makes the historic problems of Python packaging practically disappear. It masterfully hides and mitigates the symptoms. But what it isn't is a cure for the underlying disease. Those deep architectural issues, like dynamic metadata, they still exist within PyPI itself. You could say UV is the best possible shield for a flawed system.
And this leaves us with a really fascinating question for the future. By providing an experience that is just orders of magnitude better, UV has shown the entire Python community what's actually possible. It has raised the bar so high that it might just be the catalyst that finally forces the slow, deliberate process of evolving Python's core packaging standards. So UV isn't just the way out of dependency hell, it might just be the force that reshapes the entire landscape for good.